Hello, my name is Connor Iwata, and this is my presentation to the new and improved PIC flashlight. The goal, the goal of our weeks of research is to create a flashlight better than our leading competitor, the PIC flashlight. But before we get into the design, I'll be talking about some customer needs that I found through interviewing people live in person. Throughout the interview, questions were asked, answers were observed, and physical actions were also observed. After all, body language can describe a lot about how a person is feeling and can involuntarily show if the interviewee likes the product or not. I have highlighted the most important and frequent needs that the interviewee has shown and said. My interviewee demographic, or types of people that I interviewed, consisted of engineers, technicians, and people that are not related to the tech world. People like homeworkers, financiers, and bankers were included. A variety of questions were asked too. Questions I asked for personal opinions and what they think the standard flashlight should be were the main topic of the interview. I've sectioned off the three most important and frequent customer needs that came up the most. These three were handpicked by the customers or interviewees. Benchmark testing was done with a commonly available flashlight product to set a baseline example to compare a new design to the old design. The benchmark tests were based off of these three needs. Three tests were created. One last item before we begin. These are the flashlights that were used throughout the benchmark tests. Figure 1 includes a Husky brand flashlight, a Defiant brand flashlight, and the Pig flashlight. The Husky and Defiant flashlights are considered the baseline/standard flashlights. This slide suggests a procedure that was done to find the data for the standard sound level of the activation of a flashlight. Through this testing, we found the target sound level for the new flashlight design for it to be quieter than the standard flashlights. In other words, the amount of decibels shown on the meter would be how much sound our flashlight had to create or less. Figure 2 shows a digital sound level meter that was used to measure the activation sounds of the flashlight. Similar to the other slide, this slide shows a procedure done for the light test. The purpose of this test is to measure how much light each of the flashlights generated. This test procedure is similar to test A. However, instead of measuring ambient sound, we measured the ambient light and worked in a dark room. We worked in a dark room to minimize ambient light. A light meter was used to measure generated light from the flashlight. Light was measured in lux. Lux is a unit of measurement that measures how much light is created when it hits a surface. Through this testing, we could see what kind of light the best flashlight used and use those lights or better ones to create a better flashlight. Figure 3 shows the light meter used to measure the amount of light created by the flashlights. The purpose of this light test was to measure how much force was needed to activate a flashlight. This test consisted of placing the flashlight against a sturdy structure and using a force gauge to measure how many newtons of force were needed on the flashlight button to activate it. Through this test, we could determine how much force was needed to activate the best flashlight. In this case, the less force needed to activate a flashlight was considered the best one. The lower the activation force, the easier it was to use. Figure 4 shows the force gauge that was used to find the activation force required to turn on the flashlight. Some functional models that we used in the design process of the flashlight were the exploded view of the pig flashlight, a predictive sketch, and C sketches created with other members of the team. Figure 5 shows the exploded view. The exploded view allows one to quickly find or be able to order a part. The exploded view also provides closer details on each part such as shape and size. Finally, the exploded view shows how the flashlight was assembled and the relationships between parts. This information helped the redesign process with insight on how the parts worked and their functions. I use this information to create a better flashlight with improved capabilities. We disassembled the flashlight by unscrewing various parts and then studying their relationships and functions. The drawing you see was created on Illustrator. This is a predictive sketch of the pig flashlight. This was one of our first designs that was done at the start of the project. The point of the predictive sketch was to create a beginning design for a type of flashlight that was similar to the pig flashlight. Creating a copy of the leading brand of flashlight could give us insight on how areas of the flashlight could be better, and it gives us a starting point for a design. Figure 6 shows the predictive sketch created. To help explore other kinds of designs, we use a C-sketch. A C-sketch is a method to create designs for yourself and share with others to collect comments on designs to help make the best decisions. The C-sketch shown in Figure 7 includes prototypes for other designs. When comments are placed on other possible prototypes for flashlights, it invites creativity from all parties involved and allows for a more unified mind to have a common design. Each picture of the three shown in Figure 7 has other team members writing in different colors to show how they were involved in the design. Figure 7 also has some redrawn text boxes for neatness of writing. Through our extensive research and testing, we believe we have come up with a new and improved design, shown in Figure 8. I present to you the new and improved Pig flashlight, one with many new features and handy tools. It is activated and deactivated by pushing a large sensitive button in the middle of the case that requires very little force. The button is also designed to be as quiet as possible. The lights will default to a brighter white light compared to the benchmark flashlights. We noticed that the Pig flashlight did not have features on the lights that could be useful through the exploded view. Our flashlight includes a button panel on the top of the new flashlight that will switch light modes between plain white light, black light, different colored light, for example red, orange, and yellow, and SOS Morse code signal. The design for this panel was taken from the C-sketch. The flashlight includes a built-in compass to help navigate. The lighting is generated by LED lights which are bright, long-lasting, and require lower power than regular non-LED light bulbs. Grips on the side also make it more comfortable and easier to hold. A strap is included to help carry it. The flashlight uses only two AA lithium batteries to power. The case is durable, water resistant, and lightweight at only 0.5 pounds in weight. All of these features improve upon the existing flashlight by fulfilling the customer needs and being more usable compared to the Pig flashlight. For example, this flashlight is useful for a large demographic of people, not just the demographic we interviewed, but also people such as campers, police officers, people in places with frequent power outages, and people of all ages. Thank you for listening to my presentation on the new and improved Pig flashlight.